This time, I'm going to talk about agglomerative clustering in Python. First, let's see what is cluster analysis. Cluster analysis is the task of grouping a set of objects in such a way that objects in the same group, or we call it cluster, are more similar to each other than to those in other groups or other clusters. When we do cluster analysis, we don't know certain component should belong to which cluster. So cluster analysis is unsupervised. There are many different methods in cluster analysis. In this video, I'm going to use agglomerative hierarchical clustering. So first, we have all our data points, and then we will group two of those data points who are similar to one group, and then we group more similar components into a bigger group, and then we group such similar groups into one bigger group. So we keep doing this until we reach the whole group. When we do the grouping, we don't know how many group or how many cluster we should have. For example, if we stop here, we are going to have two groups. But if we stop here, for example, at 5, we are going to have 3 groups. If we stop at 3, at this point, we are going to have 1, 2, 3, 4, 5, 6. So, depends on where we stop, we are going to have different number of clusters. The data I'm going to use in this video is about America's economy. So we have GDP, debt to GDP ratio, S&P 500 index, etc. I have those 7 factors in my data set. Because there are 7 components, it's difficult to present in a graph. Principal component analysis is a linear dimensionality reduction technique. In this video, I'm going to reduce the dimension to 2 dimensions, so I can easily draw a graph and show the result. I had another video in my YouTube channel about principal component analysis. You are welcome to watch that video first. Briefly, principal component analysis work like this. For example, we have a dependent variable y, and then we use all 6 independent variable try to predict this dependent variable y. And at the beginning, we can write a formula something like this. With principal component analysis, for example, we want to reduce the independent variable to 3 variables. What we do is we are going to transform all those 6 variables to 3 principal components, and then we are going to calculate dependent variable with all those 3 components. So in this way, we can reduce the independent variable from 6 to 3. In this video, I'm going to reduce the independence variable into 2. As I explained, agglomerative clustering works like this. We are going to group 2 similar components into one group or cluster first, and then group more and more similar groups into bigger groups. In order to evaluate our clustering, we are going to use silhouette score to evaluate our clustering, to decide where we should stop for this grouping. We can get silhouette score here, here, and here. Depends on different number of clusters. If we have largest silhouette score around here, we are going to choose those clusters, and then we are going to have 3 clusters for our final result. Now let's go to Python to see how we are going to implement that. Now let me show you the data I used in this video first. I went to the internet and download historical data about GDP, debt to GDP, S&P 500, etc., all related data, and saved in the Excel spreadsheet. And then I loaded the data into Python. You can see these are the data I loaded. At the beginning, I had 7 variables, and then I used principal component analysis to reduce the dimension into 2. You can see after the PCA analysis, I only have component 1 and component 2. 2 components remains. And now we are going to perform agglomerative clustering. As I explained, we group 2 data points to one small cluster at the very beginning, and then we will group more and more similar clusters into bigger cluster and going up. Let's see what it looks like if we have only 2 clusters. You can see if we only have 2 clusters, it shows something like this. And then I print out all the cluster numbers for each data points. You can see at the beginning it's all 1, and then it's cluster 0. If we open this Excel spreadsheet, we can see from April 1966, this is all cluster 1. If you keep going, and then to this point, it's about October 1994, switch to cluster 0. all the way to April 2019. We can check the unemployment rate. You can see here it's about 10%, and it belongs to cluster 1. And if we check all those data points in cluster 0, it has very low unemployment rate. We can check other variables as well. In short, we can conclude the cluster 0 means good economy, and class 1 means bad economy. So, with 2 clusters, we can say the economy was bad from 1966 all the way to 1994. And after that, it's all good economy. Now, let's go back to our Python program. So, what it looks like if we have 3 clusters. You can see with 3 clusters, the data separates something like this. Okay, how about 4 clusters? With 4 clusters, we can see the data was grouped like this. And originally, with 3 clusters, this is 1 cluster, and if we break them down, and then this big group will separate to these 2 groups. Okay, how about we go even further? Now we have 6 clusters. Look like this. And if we keep going, we can separate them into 8 clusters. Unfortunately, we don't know we should have 2 clusters or 3 clusters or even 8 clusters. Now it's time to give them some score. Okay. Now we calculate this syllabus score. You can see with 2 clusters, it's about 0.6. And then the score came down and then went up. But even at the peak, with 8 clusters, still lower than the score for 2 clusters. So I think 2 clusters is our best choice. This is how I perform agglomerative clustering in Python. Please provide your comments and subscribe to my channel. Thank you for watching.